Good day. Today we're going to be doing modeling with composition functions. Alright, I have a couple different types of examples here to show you. I'm going to work an example. The rest of them will be the work for today. Alright, Renee's friends are trying to plan their annual hiking trip. They have come up with the following functions to help them choose between different hiking locations. Based on the table below, what does function h of g of b represent? Alright, I'm going to start at h, and I'm going to look at the output, because this is what I'm talking about. I'm talking about the time spent hiking. Well, that leaves me a through c. I know it is not d at this point. Alright, since I know this is the time spent hiking, let's look at the inside. G of b. Well, G is the difficulty of the hike, but I don't really care about G. What I do care about is B. I do want to show you something good to notice, though. The difficulty of the hike is G. Look what the input for H is. It's the difficulty of the hike. Those two are pairing together. This inside, though, is what I'm relating it as. So this is the black line, the time spent hiking, as a function of the temperature and altitude during the hike. C is my answer. I'm going to leave that one for you. Try one of these two. A physicist is studying air resistance on an object moving in a straight line. The drag force is modeled by the function f of v, where v is the velocity of the object. The function v of t is modeling velocity of the object over time. What does f of v of t represent in this context? Well, f is the drag force. So I know I'm going to be talking about the drag force as a function of something. So it's not the velocity for A or for D. And I'm wanting v of t. Well, the t is on the innermost part, so that is what I'm talking about the function of. What is t? T is time. This is the drag force on an object as a function of time. B is the correct answer. Speaking of drag force, let's look at that on number, well, I don't really have numbers, but on the next one on the bottom right. By the way, these are two separate problems. In case that wasn't clear, they are two separate problems. A physicist is studying air resistance on an object. F of v is the velocity of the object. V of t is the time. Express the drag force on the object as a function of time. Well, F again is the drag force. So, F, and I'm wanting to use the other function, v of t. Really, this v is not important because ultimately I'm going to be putting this as f of t. This is the drag force as a model of time because I am going to be combining these functions in this problem. So f of t is equal to the f function is what goes on the outside, the v of t function is what goes on the inside. So 0.05 parenthesis. Why parenthesis here? This is the location of the v in the first equation. So parenthesis. 15e to the negative 0.3t power, close parenthesis, and include my square from the original function. All right, there is that finished. Let's move on. You have several word problems to do. I'm going to work two of them. I'm going to work the first one on this page and one of those. Probably the number of bacteria. Benjamin works at a furniture store. He receives a $220 weekly salary plus a 3% commission on sales over $5,000. If we assume he is selling enough this week to get the commission, I have the two functions f and g. Which of the following would represent your commission? So I have two options. I have f of g of x, and if I have f of g of x, I'm putting the g inside f. Therefore, I'm having 0.03 times x minus 5,000. What this is saying is anything over those $5,000 is going to gain 0.3 or 3%. So if I sold furniture worth $5,001, I would gain an extra 3 cents. 1 times 0.03 is 3 cents. Okay. The other way to do that is g of f of x. If I put f into g, I have equal 0.03x minus 5,000. Now what this says, I'm going to take the sale, multiply that by 0.03, and then subtract $5,000. Let's say I sold one item in this. That would be 0.03 minus 5,000. This function is going to give me negatives. This gives negative numbers. It does say assume he sells enough, so let's put in 5,000 for x. That is still 0.03 of 5,000, which is still going to give me negative money. It cannot be g of f of x. F of g of x is the correct composite function. All right, I'm going to do number bacteria. The number of bacteria B after H hours is given by that function. The mass M in grams of B bacteria is given by the next function. After composing the functions, determine the mass after 8 hours. All right, first I'm going to compose these. So I am looking for the mass after 8 hours. The mass is my output, which means I'm putting in hours as an input. So M of H, and I'm going to rewrite this as M of B of H, because they are the same thing, equals. All right, start with the outside function, 0.002. Instead of B, I'm going to be putting in my uppercase B, the bacteria function, 50 H plus 100. Now, one thing I want you to note, it is imperative that I understand what the functions are doing. So here's my question. What is that plus 100? You can understand how it's gaining 50 bacteria in H hours, but that only works if I have an initial amount. This plus 100 is the initial amount of bacteria. You have to be able to know bacteria. Y'all, I'm a math major, not English. I'm pretty sure that's, oh, never mind, it's spelled right there. It is correct. That is the initial bacteria. You have to be able to know how to identify the real-life applications to these problems. All right, now let's solve the rest of it. Determine the mass after 8 hours. So this is going to be M of H of 8. And I'm writing this, it's really M of B of 8, but for simplicity's sake, I'm just writing that, where 8 is the H value. So 0.002 times 50 times 8 plus 100. This is 500. 1 gram. The last thing I want to make sure you put is this unit. So these are word problems, you have to include the units. Whether that be grams, whether it be, let's see what Colton's doing, distance in meters, whether that be chapters. Whatever you're talking about, you have to put that unit. All right, try the rest of these problems. You have 1, 2, 3, 4, 5, 6, 7 problems to work today, and you are done with modeling composition problems. All right, I hope you have a great rest of your day.